Good afternoon, 8th graders. We're talking about evaluating powers today and also combining them if they're being multiplied or divided. This will be page 8 in your notes. So just to review what a power is, it's really just a shortcut for multiplication or division. Now the division part is something we'll talk about in a later lesson, but for now, let's just think about multiplication. So, for example, 4 to the 9th, that's power, and that's a shortcut for a division problem. And if we pull this down, we'll see a few definitions. The power consists of two different things. The base. The base is your bigger number, and then the exponent, which is the small number in the top right. Now the reason we call 4 to the 9th a power is because it represents the following multiplication problem. So 4 multiplied 9 times. That's a lot easier written as that power, 4 with the 9, instead of having to write 4 9 different times. The exponent tells us how many times we're going to multiply the base. So a positive exponent tells us to multiply, and then in the future we'll talk about a negative exponent telling us to do something else, which you might remember we've talked about it. So maybe think about that. We'll talk about it in class tomorrow. Okay, now we're going to take a few problems that are multiplication problems and write them as powers. So this first one, 6 is a factor over and over and over, so that's our base. And then when you count it up, there's 4 of them, so that's our exponent. Negative 2 is our base in this one. And when you're writing it as a power, if it's a negative number, make sure you put it inside of parentheses. It's repeated 3 times, so our exponent's 3. Here we have 5 as our base, and it's repeated 6 times, so our exponent's 6. And then you're going to do A on your own. So go ahead and pause right now and do that on your own. Okay, now we're actually going to solve some. So negative 3 to the 3rd exponent. So we could write this out as a multiplication problem and think to ourselves, what's 3 multiplied 3 times? 27. And we have to use our signs rules for multiplication. There is an odd amount of negative numbers, so that would be a negative answer. 4 multiplied 4 times. Let's do this one. And we can do 16 and 16 like this, and I think if you do that, you get 256. I think, yeah, that's right. All right, you're going to do number 3 real quickly, so pause right now. I want you to try number 3 on your own. Okay, so you should have done number 3 on your own. It's one of the trickier ones. So if you think about this, I'm not going to write it out. It would be negative 1 multiply over and over 22 times. So that's a lot of negative 1s. But anytime you multiply anything by 1 or negative 1, its absolute value doesn't change. So in this situation, it's just going to stay 1. But then you have to think about how many negative signs we had. We had 22 negative signs. That's an even amount of negative signs, so that makes my answer positive. All right, and you're going to do number 4 on your own and bring it into class tomorrow. Okay, this is where we're going to talk about multiplying powers. So 2 powers can be multiplied by each other, and you can group them together if they have the same base. So for example, if I had 6 cubed multiplied by 5 to the 7th, what we're about to do will not work. You cannot do it. That base number, the bigger number, has to be the same. So here we have our example. Write the following numbers 1 power, 4 base, 4 exponent, 4 base, 3 exponent. Now I did it out the long way. So I wrote 4 of the 4s and then 3 of the 4s. Now when we combine all of that and we write it as a power, it's 4 with a 7 exponent. Just count up those fours, and there's 7 of them. Now, what did you guys notice? Look at the original problem and the exponents, and look at our solution. And see if you notice what we did. It's pretty simple. So this will be our rule. Anytime we have 2 powers with the same base, in this example there were 4, and they're multiplied, we keep the base, we kept the 4, and we just add the exponents. Now, you do need to be careful about signs, because say one of these was a negative number, we can't trust that addition. We have to think about our signs rules. If the signs are the same, we add. If the signs are different, we subtract. So that makes a difference in this situation. Okay, let's try A. So A, we're going to look at it, and let's see, there is the same base, 6. Our directions are important because they tell us to write the following problem as 1 power. They don't tell us to evaluate, so we don't have to do all this math, which is great because that'd be a huge number. All we need to do is put together these powers. So in the situation, the 6 stays. We keep the same base, and we just add the exponents. So that gets us a 26 exponent. And for now, this is all you're going to need to put. That's going to be your answer. B. All right. 8 exponents are the same, so we can put it together. Now we add the bases. Actually write out the addition problem. And this is where you're going to notice, all right, they are not both positive. I've got a negative number and a positive number. I've got to use my rule. Different signs, subtract. So I subtract these, I get a 1. And you also need to think about the answer of your sign, or the sign of your answer. We keep the sign of the larger number, so it's a positive 1. You're going to do C on your own, so bring that into class tomorrow. And the D is a special situation. It's like I said before, we don't have the same base, so we cannot combine these. And we just write that, cannot combine. And if you want to just abbreviate and put C dot C dot, that would also be okay. So you're recognizing there's no way to write this as 1 power because they're not the same base. I go and turn over. Okay, so here we have kind of the same situation. Ignore that bottom part for now. If 2 powers are divided, so here we have 6 to the 5th exponent divided by 6 to the 3rd exponent. If they have the same base, we can put them together. So here we have our division problem. I wrote it as a fraction in the blue, and then I kind of expanded it right below here. So 6 to the 5th, you should be able to think about it as 6 multiplied 5 times, 6 to the 3rd, 6 multiplied 3 times. Now we can reduce these 6's in the top and the bottom. So I'm doing 1 at a time. And then we can get our solution as 6 squared. Now comparing that to our original problem, you should notice we kept the same base, and then all we did was subtract the exponents. We did 5 minus 3, and that was our new exponent. So whenever you when you multiply powers with the same base, you add the exponents. When you when you divide powers with the same base, you subtract. And the division sign is more similar to a subtraction sign, so maybe that'll help you remember it. And again, we also have to be careful about signs. Okay, number 1. Same base, so we can do this. We can write it as 1 power. We keep the base, and then we subtract the exponents. So that's our new power. We aren't evaluating, we're just keeping it. 7's our base, and we just subtract the exponents, and that's our new exponent. All right, I want you to pause real quickly and do 3 on your own. So go ahead and pause right now and do that on your own. Okay. So just because the base is a variable, it really doesn't make a difference. Just so it's the same variable, it has to be the same letter. So F is our base, and then let's write out this subtraction problem. Now notice what I had to do. That negative sign on the 5 is not our subtraction sign. What I put in the middle, that's our subtraction sign. And the negative sign doesn't go away on the 5. Now we're going to use our signs rules. So a negative number and a positive number. So we do subtract here, which is good, because they're different signs. The number will be 3, and we keep the sign, the bigger number, which is going to be positive. So it's f to the third exponent. All right, so be careful about those signs. Remember, write out the problem like this I have right here. If you try to do it in your head, you might make a mistake. It gets a little confusing. All right, you're going to do number 4 on your own and bring that into class tomorrow. And that is all we have.